Welcome to the 2021 Vector Forum. My name is Ingo Alfter. I'm working since 21 years with the ZF, now within Division A for active safety. There I'm responsible for the so-called customer product platform development for brake system and steering systems. With the title Innovative Software Concept for Safety Products, I want to give you in the following 15 to 20 minutes a short overview on our software platform concept that we have developed for those safety critical products. And I'd like to give you a little bit insight on the current and maybe future vehicle architecture we recognize and what that has as an impact or what that drives as a change for our brake control and steering systems. Division A ZF is the division for active safety. And within this division, we have all the products that are related to brake systems. So all the brakes on the four wheels, all the electronic brake components, and the steering system is included, the steering at the front wheels. So ZF in total has a portfolio with a rear axle steering, but this is belonging to a different division. Here in the overview, I marked in yellow all the elements where software is included, and that definitely grew in the last decades. And we see some trends that it's even more growing and it's even becoming more complex because the trend is to become smart actuators in parallel to full brake system or steering systems, and exactly that is what I'd like to show. So the vehicle market. The Vector Forum is named Software-Driven Innovations. On ZF, we call it the software-defined car. So we assume that in the next years, with all the digitalization and with the market trends, we will have challenges or improvements on the hardware. Like, as already mentioned, we have smart actuators, so actuators that become more intelligent or actuators that will be used in conjunction with higher level functions. We will have more intelligent sensors. We definitely need more processing computer power. And what we clearly see is that on the vehicle market, there's a trend to go to domain or zone-based electronic architectures. I come to this on the next slide. For the software development, that means we will need to find a way of becoming more hardware independent, so software modules could be relocated on different ECUs. That is in line with the flexibility, scalability, compatibility, and very important upgradability. So as we are all very familiar with the software upgrades we receive on our smartphones in the future car, this will become very similar. But nevertheless, we believe that the combining of certain comfort and handling functions, that this may move into the domain or zone-based architecture, but not for all the systems. So we will definitely not eliminate a brake control, or we will definitely not eliminate a steering system. Here, I try to create a slide that shows over time where we are, where we may walk. So all the vehicles we are very familiar with, the classical architecture the last 10, 15 years have been, they are individual single ECUs, somehow connected through bus systems, but the entire functionality is more or less on one single controller. Connected through a gateway, you have the possibility to perform diagnostics, and that is, let's say, the classical architecture where all the functions are only located on a single ECU. On a domain-oriented vehicle, a function may be computed at a higher level and then distributed to some smaller ECUs like smart actuators. And even on the future stuff where we have zone or cloud-oriented architectures, you may even get new release functionalities within your car, or even on there are ideas that cloud computing is active while you're driving. So that means the trend is really to have more software innovations, and something like functions on demand or pay-per-use may come. But for the safety critical functionalities like steering and braking, we will still have dedicated safety related ECUs, and we call those the backbone functions that will definitely reside in the individual ECU. So for a brake system or a steering system, that means we have to control the brake force or the steering force, the brake torque, and this requires safety ECUs. This requires that we have dedicated ECUs fulfilling a certain safety level, whereas the power computing ECUs on the backbone of the car, they may have different architectures and different safety levels. So what does that mean? Finally, as long as we have four wheels on a car, braking and steering systems really remain as a safety actuator in all the vehicle architectures. And we need to support the, as I call it, classical one ECU software architecture as we have today. But we need to be ready for the future domain or zone-based vehicle architectures. And that definitely requires a scalable architecture even today and in the future. So looking a little bit deeper into our architecture today, it's a classical AUTOSAR-based architecture. So we will have a microcontroller, an ECU abstraction layer, we have some services, and then we have a control software. The full set of the brake control or steering control is in the entire architecture of our own ECU. We definitely have already today some black box applications, some customer-owned software for certain elements, but it's a one ECU, it's a one box system, and already today we support multiple variants of the architecture, such as the simple system where everything is coming from ZF, the platform. So that is the layer below the control software and the control only from ZF. Then we have the same architecture where the OEM is placing some black box. I think I presented this in 2018 on the Vector Forum, that we have a virtualization, so that there's a platform which contains our control and a platform that contains whatever other OEM, and it behaves as if it would be two ECUs. We have already today in development systems where some certain features are provided as a black box from the OEM. So they exchange, for example, our traction control with their own traction control. Then we have already in development a OEM that is creating the entire logic for a brake system by himself, and only the actuator part is coming from ZF, but still on the same ECU. The next architecture would be that this is then moved outside into one of those either on the domain level or zone level, and we have it in-house as well. It's the ZF Cubics, where we support for multiple actuators such as brake system, steering system, and damping systems, a high-level vehicle control architecture that is running on a different ECU. So, but what you see here, we always have this underlying platform concept, which is then really close to the microcontroller or is close to the OEM base software, and how to make sure that we can develop the platform individually, independent of the final architecture. That is now the scope of the next slides. So therefore, we decided we need to have somehow a concept that allows a more independent development of a platform, and therefore we layered our software more or less into 4 levels. We have the lowest level as the base software, which is close to the hardware, close to the brake or steering system. The next level, and that is the responsibility where I'm responsible, is the so-called customer product platform. This is the platform that includes each and every customer-specific element, such as the communication stack, the diagnostics control, and the specific AUTOSAR adaptations from the customer. And then we decided to have the level 3 as the product controls. That could be either our own or a different from another OEM, or it could even be relocated somewhere else in another ECU. And the final software then is the level 4. And to be able to develop the customer product platform solely, I need to decouple the development from all the interfaces we have to the other layers. And therefore, we decided to create so-called stubs for this. And that was really a challenge because in the past, all the interfaces between our own ZF control and ZF customer product platform layers, they were kind of legacy. They have grown over the last 15, 20 years. And therefore, it wasn't that easy to really extract those. And we started with a software architectural model, and we recognize that even those stubs, they need to have a minimum functionality. So some small logics need to be included, such as a confirmation on coding, such as feedback on certain state reactions. And we started last year to really investigate in all the interfaces that exist. So we went through the entire software that has been developed throughout the last 20 years. We created a list of all the interfaces. We transformed them into AutoSAR interfaces, AutoSAR components. And meanwhile, we have this totally modeled. So each and every interface is modeled in Rhapsody. We can auto-generate now the RTE, and that really allows us to have either our own control software from someone else, or even to eliminate control software entirely and develop the rest more or less independent. We even went one step further to create a certain level of testing. So we are able to generate those stubs out of the Rhapsody model, including the required small logic. We have developed our own AutoSAR tester that is really looking into the port connections. And we generate an automatic list of test specification so that whenever we enhance the interfaces or whenever we change the customer platform level, we can easily rerun the tests to ensure that everything is still matching. So this is now live in the first project since the beginning of this year, and it really showed an improvement in the release process of our projects, because now the teams really can independently develop on their side of the interface. And even today, with the team spread throughout the entire globe, so vehicle or performance application in North America, base software in Europe and India, it is even because we are decoupled, we are in a very good situation to have the teams independently develop on their platform. And when we then finally integrate the entire software, since the interfaces are prior defined and tested, we are getting less trouble as we had in the past with final software integration, where then incompatibility on interfaces have been detected. To summarize, so we have seen that there is a market trend that goes into multiple different vehicle level architectures, domain or zone or cloud-based architectures, that is then definitely requiring a scalable architecture on the safety critical controllers like brake system, like steering systems. We, in the software development, decided to tackle on a platform concept that allows the stepwise development, the stepwise integration, and of course then, as I already mentioned in an early phase, independent testing, independent development, so that we are sure within the different architectural usage later on in the vehicle, we can develop our stable and sufficient tested platform underneath all the different architectures. So thank you for listening to my speech, the innovative software concepts for safety products. I hope that I was able to show you, coming from the OEM architectures for vehicles and their future development, the impact that this have to the architecture of our brake control or steering control systems, and how we tackled this with the ZF platform concept, where we believe that with the stepwise development and stepwise integration, and of course the early testing, we are open for those future challenges. So now I'm open for your questions, and I hope that you have some questions. Thank you.